Hello, seventh graders. We are going to be solving inequalities. So when we solve an inequality, we're going to be solving inequalities just like we would solve equations. So a couple of things. Our goal is to get the variable by itself, and we're going to do that by using our inverse operations. So ask yourself what's happening to the variable, and then you want to undo that and do the same. Whatever you do to one side of the inequality, you want to do to the other side of the inequality, just like we did with equations. So, for example, if we look here, we have an equation. All right, we had x plus 3 equals 8. So some number plus 3 has to have the same value as 8. We started off by adding 3, and so we wanted to undo that. We ended up subtracting 3, and we did that to both sides. Over here, the positive 3 and the negative 3 zero out, leaving us with just x. And then 8 minus 3 gives us 5, so x is equal to 5. When we were solving equations, maybe you just wrote your answer was 5 and circled it, and that would work. When we solve inequalities, we're going to do the same process. So we have x plus 3 is less than 8. I want to undo the adding 3 by subtracting 3, or you can think undo positive 3 by adding a negative 3. Either way, they mean the same thing. And so my 3's over here zero out, leaving me with the x. My 8 minus 3 is 5. When we have an inequality, we have to be sure to write our final solution as an inequality. So x doesn't just equal 5, x is any value less than 5. So we need to make sure that we communicate that in our solution by writing out the whole inequality comparing a variable with a value. So x is less than 5. If I was going to graph this, we would want to have, again, we usually just put 3 numbers on a number line, 4, 5, 6. So because I'm comparing my x to 5, I'm going to have an open circle at 5. It's open because x cannot equal 5. And then all my values less than 5. And so I should be able to plug in any of those numbers. All right, so right now I'm saying, for example, that x could be 4. So if I plug 4 back into my original inequality, if I plug in a 4 instead of my x, all right, and plug this in, I should end up with a true inequality. So 4 plus 3 gives me 7. 7 is less than 8. Yep, that's true. And so that means I've shaded the correct part of my number line. So I'm just going to walk you guys through a couple of different inequalities, just so that you get the idea of how to solve them. And because these problems are so big, I'm actually going to write them off to the side so that we have a little bit more room to solve. All right, so here I have 6 is less than or equal to y minus 4. My goal is to get the y by itself. So right now I was subtracting 4 from y. So I need to add 4. So I undo subtraction by adding. That's going to zero that part out. Whatever I do to one side, I want to do to the other. So 6 plus 4 gives me 10. I'm left with y over here. And then I'm going to bring down that inequality symbol. So I have 10 is less than or equal to y. Sometimes inequalities are easier to understand if our variable is on the left. So I'm actually going to rewrite this as y, and then I want to make sure I flip that inequality is greater than or equal to 10. And so now if I were to graph this, I'm going to have 3 numbers on my number line, 9, 10, 11. This time I'm comparing y to 10, so I'm going to have a circle at 10. This time it'll be a closed circle because y can equal 10, and then y is greater than 10, so I'm going to shade all of my values to the right of 10. And then just to check it, I can plug in any value that's greater than 10. And I'm going to look at my original inequality. So I'm just going to plug in 11. And I just want to determine that this is true. So if I plug in 11 for y, 11 minus 4 gives me 7. And then if I compare my inequality, I have 6 is less than or equal to 7. That's true, so that means I've shaded the correct part of my inequality. Here we have some practice with negatives. So a minus 7 is greater than or equal to negative 3. What's happening to my variable? Right now I'm subtracting 7. I want to undo that. So we're going to add 7 to both sides. Over here, my negative 7 and positive 7 zero out, leaving me with a. On the right-hand side, negative 3 plus 7 would give me 4. And then I can bring down that inequality symbol, so I get a is greater than or equal to 4. To graph this, I'm comparing to 4, so I for sure want 4 on my number line. And then I usually just put a number less than 4 and a number greater than 4. When we graph this, I'm comparing to 4, so I'm going to have a circle at 4. A can also equal 4, so that means this is going to be a closed circle. So I'm going to shade it in. And then all my values greater than 4. So I can shade to the right-hand side of my number line there. If I plug in any number from the right-hand side, remember this is a number line, it goes on and on forever and ever. So this is going to include 5, 6, 7, all the way, it includes 3,280. It includes 5.5. It includes all the numbers that are greater than 4, greater than or equal to 4. So if I plug in any one of those numbers into my inequality, I should end up with a true inequality. Because there's some negatives here, I'm just going to plug in like a little bit larger number. So I know 20 is greater than 4, so I'm going to plug in 20. So 20 minus 7 should be greater than or equal to negative 3. And 20 minus 7 is going to be 13. And 13 is greater than or equal to negative 3. That does check out, so I'm good. We can also solve one-step inequalities using multiplication and division. So here I have 3 times g is less than negative 9. The 3 is being multiplied with the g, so I want to undo that. So to undo that, I need to divide by 3. 3 divided by 3 is going to simplify to 1. They're going to 1 out. And then because I divided the left side by 3, I'm going to divide the right side by 3 as well. Negative 9 divided by 3 is going to give me negative 3. I'm going to bring down my inequality. And so then again, we need to write our whole entire solution as an inequality with a variable, comparing it to a value. So g is less than negative 3. To graph that, I want negative 3 on my number line. I'm going to go ahead and put negative 4 and negative 2 on my number line. I'm comparing g to negative 3, so I have my circle there. This time it's an open circle because it cannot equal negative 3. And then all my values less than negative 3 would be to the left. If I plug any one of those numbers in to my original inequality, it should be true. So let's just take the negative 4. So if I do 3 times negative 4, 3 times negative 4 is going to be negative 12. And negative 12 is less than negative 9. All right. As you're comparing negatives, you want to keep in mind which one is further on the left and which one's further on the right, because comparing negatives less than and greater than can be a little tricky. On this one, I have negative 5 is greater than m divided by 2. I want to undo the division. I'm going to write this one a little smaller. So I want to undo my division by multiplying by 2. And when I do that, what I end up getting is m times 2 is 2m, 2 times 1 is 2, and then 2m divided by 2 2 divided by 2, 1's out, so I'm left with my m. All right, whatever I do to one side, I want to do to the other. So I'm going to multiply this side by 2. 2 times negative 5 is going to be negative 10. I'm going to bring down my inequality, so I have negative 10 is greater than m. To help me understand that a little bit better, I'm going to rewrite it with my variable on the left. So m is less than negative 10. This is the only point where if you want to think of alligators, you can. My alligator was eating my negative 10 here, so it needs to still be facing the negative 10 when I flip that, okay? So I get m is less than negative 10. When I graph this, this is going to be my open circle at the negative 10. All values less than negative 10 can be a solution. And so then I would have my arrow to the left. And there's some practice with decimals and fractions as well. This is hopefully just a quick little review of how to solve one-step inequalities. So you're using your inverse operations to get your variable by itself. Have a great day.